to be here with you this afternoon to talk about open source and AI. It's amazing to see the rate and pace of open innovation in AI. And IBM is no stranger to that. We've had a history of encouraging, contributing, and harvesting open innovation with Linux, with Eclipse, with Java. And we see it no different in AI. If anything, we see the opportunity for open innovation in AI to be the most dramatic that we have seen in decades in IT. So let me do three things with you in the next half an hour we have together. First, I want to share with you a perspective on what is open innovation in AI. Where is innovation happening? What projects are out there, especially for the developers, the startups, the faculty, the students in the audience. Where can you engage in the open innovation community? Second, what are we doing in IBM to participate and contribute to the open innovation? And how can you touch and feel the technologies that IBM is contributing in the open? And the third is we give you a sense of how we're taking that open innovation and bringing it to market through products. You heard Dinesh this morning talk about the importance of harvesting innovation in products, and I'll give you an examples of what we are doing there. But let me first start with some data. So here is a chart that talks about what's happening with AI innovation in the community out there. Hockey stick curves that talk about the rate at which new projects involving AI are getting created, their interest, and this is from the 2024 AI Index report. Anytime you see a curve like this, independent of the fidelity of the data, you know something real is going on. And these are just amazing growth numbers. Now, if you look at models, as I'm sure we're all familiar with, models are the central artifacts of modern AI. And if you just look at models alone, over 2/3 of the model released last year were open models. And these weren't just released. Let me give you another amazing statistic that I found out recently that I couldn't even put on the chart. In terms of the enterprises that have managed to scale at least one use case into production, recent surveys indicate that over 55% of those use cases actually used open models, not proprietary models. So that's an amazing statistic that tells you open innovation in models is starting to happen, is real, it's useful, and it's getting adopted. So if you step back and ask yourself what open innovation in AI means, it's useful to think of it, at least for me, in sort of two big buckets. And I'll explain to you why I think these buckets are useful to separate. The first bucket, which is all the icons on the left-hand side box, are models. These are scenarios where, whether it's Llama from Meta or Mistral, and I'm going to talk about what IBM is doing, or whether it's Gemma from Google or others, models are being released in the open, which means as developers, you can pick up those models and use them. That's open models. And this is by no means a complete list. On the right-hand side is open source technologies that let you work with those models, serve them, quantize them, optimize them, infer them, tune them, adapt them. Anytime you imagine attaching a verb to a model, there is an open source project out there that lets you do that efficiently and effectively. And again, I will talk about what some of the most impactful open source projects are there on the tools and runtime side. And this is now a growing ecosystem. If I actually tried to put all the icons, I would have 8 pages of just icons out there. That's how rich this ecosystem is. At IBM, we have decided to embrace and are doubling down on open innovation on both fronts. With respect to models, we're releasing, and we released in open source just a few months back, a series of models that we call Granite models. And I'm going to talk about what those models are, why they are special, and what we have released. That's on the models front. On the right-hand side, we are investing in a few key open source technologies that we believe are foundational to the AI stack. As AI starts to become mainstream, and Gen AI in particular, what are those open source technologies that we believe are foundational to the AI stack that will eventually become, we think, the de facto stack out there? And I'll talk about the projects that we are investing in and what those projects do. So that's sort of the plan: models, tools, and runtimes. So let me jump in right to Granite. OK. So what I have here is a busy chart. The only key takeaway for all the students and developers, if you can, scan the QR code, visit our Hugging Face page. This is the page on which you will see all the models from IBM, the Granite models, that we have released in the open. I'm very comfortable in saying this is the largest collection of multimodal, high-quality performant models released with an Apache 2 open source license that lets you use them to build, innovate, and build applications. And there were a few key design elements that we thought about in releasing those models. Number one, as you see, there is a variety of models. Models of different sizes and shapes that let you work with depending on your applications. Number two, this is about choice to developers. And we increasingly see language, code, and then time series and geospatial data as important modalities for applying AI. And we have released state-of-the-art models in all of these domains. And again, we're just getting started. So watch this page. You will start to see more and more models coming out of IBM in this space. I just wanted to give you a sense, of course, of what's special about these models. The best way, of course, is to go there and try it out yourself. But let me give you a few results in each of these model categories. First, before I get to specific models, in terms of openness and transparency, our Granite models are one of the top-ranked model families when it comes to transparency. In terms of you knowing what went into the model, what data went in, how it was trained, etc., we're one of the most transparent out there because we truly believe that's a key element of being open. And interestingly, within just a couple of months of these models getting released, with really no overt, if you will say, advertising, we're seeing tremendous reception. Our time series models are being downloaded over 500,000 times. So people are doing something interesting with it. I look forward to finding out what they are doing. Likewise, our code models have been downloaded over 120,000 times just from their page on Hugging Face. And we're already starting to see community contributions. So those of you out there who are keen to play with models, you're welcome to join this community and start contributing to both use and evolve our Granite models. Now, what's special about these models? So let me give you a few sample results just to convince you that you should go try out these models. First, our code models. Our code models are one of the state-of-the-art models when it comes to benchmark performance in a number of categories. You see a graph here that compares them with a number of other models in the same category, models that are in the size of between 0 and 10 billion parameters, models that are efficient, you can use sometimes on your laptop or potentially with just a single GPU. And you start to see our models being as good or better in many cases than models from everything else in open source. So that's an example of the riches. Just think about it. If all you wanted to do was use AI for coding, just on this page, you have models from 4 different companies out there that you can work with and experiment with. That just gives you a sense of how rich and robust the open innovation ecosystem in AI is starting to become. A second modality is time series. And this is an interesting one because there are actually not a lot of time series models out there. So it's interesting to us that as soon as we released a time series model, we started to get a lot of reception. But if you think about it, while a lot of the use cases we see in the consumer domain in AI is around language or in code, time series is an ubiquitous modality. Whether you're working with sensors, you're working with financial data, you're working with retail shopping data, time series data shows up in every domain. And I think there is a ton of untapped potential in applying technologies like large language models to time series data. And what you see in this chart is some of the models that we have released, and there are others starting to show up that are very compact. They are less than 5 million parameters, but they provide double-digit performance gains on a ton of time series benchmarks. So I guess I'm not surprised that a number of people are downloading them and experimenting and working with them. And again, I encourage those of you who are working in a domain with a lot of time series data to try those out. Very, very interesting in new architectures and a lot of potential in a number of domains. So that was code. Now was time series. Another modality that we have been very, very thrilled to work on in IBM is this whole world of geospatial data. We all live on this wonderful planet, and we know there are a number of challenges, from climate change to energy to renewable resources to water management. And one of the best ways we have to sense what's happening on our planet is, interestingly, to look from above. We have enormous data sources, public data sources, satellite data, and we have been partnering with NASA, and I believe there's a demo out there. If you have not seen, do go check it out, to build foundation models on geospatial data. And we are doing two sets of models. One is models on Earth observation data. It's using a data set called HLS, Harmonized Landsat. What it means is it lets you see what's on the surface and below the surface to a few meters with a number of high-resolution frequencies and wavelengths. And we are building a model over 8 years of HLS data. And that model is built, available in open. The other data set is weather and climate data. And we have built a model in partnership with NASA on over 40 years of climate and weather data, atmospheric data, wind pressure, a number of parameters, probably the richest data source built into a foundation model. And what we are doing in IBM is taking these base models and starting to release models that address specific use cases. So there you go. So from use cases in asset management, renewable energy, weather forecasting, climate change, risk of physical assets to climate change, we're just scratching the surface on the set of use cases that one can do on these models. So, and I'm not going to list all of them, but I will encourage you again to go to our Hugging Face page and start to play with the models, both these models and the models that we have built with NASA. What I want you to leave with is that the amount of open innovation out there in model space is dramatic. IBM is committed to releasing all our foundation models in the open. We have begun to do that, and we're going to continue to do that. We intend to release models with newer architectures, more diverse modalities of data, models with richer context length. We can let you do more things, and obviously models that are compact, efficient, and usable in a number of scenarios. So just watch for what we are going to release on our Granite model series in the months and years to come. So that was on models. I want to tell you a little bit about the other side of tools and runtimes. Like I said again, what tools and runtimes are, okay, I have models, how do I work with them? You're a developer, you may be a student or a faculty, or you're an application developer. What is the technology available to work with models? And especially, how do I run them efficiently? What's happening? So we have picked 3 or 4 key projects on which we are doubling down on investing. So first project is PyTorch. It's probably the most popular runtime out there. Some of you may be familiar with Hugging Face, the world's largest repository of open models in AI. Over 85% of the models released on Hugging Face are PyTorch-compatible models. So it's the most popular runtime out there to do AI. And then you see, of course, Hugging Face itself, which releases APIs to work with models. And then there are projects like VLLM, Triton, et cetera. I won't go into the technical details, but these are projects. The way you should think about them is these 4 projects are going to become the kernel of what I think of as a new operating system for AI. As you start to think about AI not being just a layer on top, but getting built into the core enterprise fabric, the compute fabric, the projects here are starting to become the core open source projects. Those of you familiar with operating systems, think of the Linux kernel. The Linux kernel is at the heart of the world's most popular operating system, running over 70% of servers across the world. These projects, I believe, will start to be the starting point for an open source kernel that will come to dominate what we think will be the core OS that runs AI in the future. So what are we doing in IBM? And if some of you are interested in working with these communities, what kind of problems can you solve? So bear with me, the next few charts are going to be a little bit technical. It will assume that you are actually working with models already. But I just wanted to give you a flavor of what, if you are a student or a faculty or a developer, what can you do if you join these communities? So the first is model inference. What is model inference? It's calling a model. You have a model, you want to call it to get back an answer. Now, if you are building interactive applications, think chat applications, you want the model to respond rapidly because you don't want to sit and wait for that clock to wait for the tokens to come. As models get larger and larger, it takes a lot of effort, lot of compute to give you back responses rapidly. So one of the things that IBM worked on in the open community is this idea called speculative decoding. Very simply put, we built technology that says, can I guess what the model is going to produce? And instead of waiting for the model to produce one token at a time, can I predict the next set of tokens the model is going to produce? I can compute it efficiently, and then on smaller amount of hardware, I can give you good latency. So you can deal with large models on smaller GPUs, if you will. And we've seen benefits of 2 to 4x in working using this technology. So this is an example where this invention, we contributed back. It's now integrated into 2 of those projects I talked to you about, VLLM and Hugging Face. So those of you who are interested working in operating systems or building computer architecture algorithms, here is a space where there is a lot of opportunity for open innovation and differentiation. So this is model inference. How do you make model inference low latency? The other side of the equation is training. How do you train models at scale? So there again, IBM, working with Meta, put together a lot of innovation that dramatically improves training times. So compared to what is out there, we have results that, unfortunately, there's a problem with the graphic, but we have results where we are able to train large models 30, 40% more efficiently. As an example, some of the Granite models I talked to you about were trained using this technology. And as a data point, we can send 4 trillion tokens to train a model in a matter of a couple of weeks with this technique. That kind of rate would have taken 3 times more GPUs before these kinds of techniques were applied. So it starts to give you another sense of how we are starting to scale AI. All of this, again, in the open. So all of this innovation is available for any one of you to start building companies on top and doing innovation. So that was training. And then finally, the third example I wanted to give you is something that accelerates both training and inference. This is technology where we have released in the open new kernels. These are pieces of code that run on GPUs that dramatically accelerate how both models can be trained and models can be served. I'm not going to go into the technical details, but I just want to leave you with the following. There's a lot of reference here. If you are the kind of person who wants to play with this technology, do follow these links. But what I wanted to leave you with is whether you are an application developer where you want to work with models, or you are a deep tech person where you want to get involved in the technology that runs models, there is enormous scope for people of all backgrounds, whether you are an operating system person, a computer architecture person, an application developer, and of course, a core AI person to contribute innovations into the open and join a very, very rich and growing, robust community. The last project from IBM that I wanted to share with you is a project called Unitex. Unitex is an IBM open source library to help you evaluate models. When you evaluate models, one of the biggest challenges is every model is a little bit different. So if you decided to pick a Granite model, or you picked a model from Meta, or you picked a model from Google, and you are adapting it to your application, evaluating each of those models requires you to prepare your data differently. So Unitext is a library that dramatically simplifies that. And again, it was one of those amazing examples where the team did it, put it out. In a matter of a few months, this library is now integrated with the 2 most popular evaluation platforms out there called Helm and LM Eval. These words may not mean much to you if you're not in this game, but what I want to leave with you is the opportunity to make contributions. The work in Unitext was done inside of IBM by a team of, at best, 2 people working over 3.5 months. But suddenly, their output is out there in the open, getting integrated, and anybody who does model evaluation using these technologies is benefiting from the innovation of these 2 people working for 3.5 months. So I just want to leave you with the fact that AI may look complex, very expensive, hard to do, something that only big companies can do. Actually, the truth is there is a role for every one of you to do interesting innovations in this place, and this is one example of why that is actually possible. Okay, so let me step back. I told you about a lot of things happening in open innovation, but there is an interesting dichotomy between the 2 pieces that I said. So when I talked about models, I talked about IBM singularly. I said IBM created Granite models. I said Google creates Gemma models. Meta creates Llama models. What does that mean? The task of creating a model is not a community activity today. It's a single company, a single organization producing it. Yes, the model is in the open, but you can only use the model, do what you want with it. The act of creating the model is not a community activity. Whereas when I talked about all the work on the other side, I said we collaborated with Meta, we collaborated with Hugging Face, we collaborated with VLLM. So tools and runtimes is much more like traditional software. If you're familiar with open source software, contributions to an open source software come from a number of places and they get integrated. That remains true on the right-hand side. On the left-hand side, models can be open, but today they are really a monolithic activity. It's one company, one team building models. So this got us in IBM research thinking a little bit, can we change the game? Is there a way in which we can make model development a community activity? Can communities collaborate to incrementally improve a model, as opposed to simply waiting for somebody to give a model and use it? And that's where our team came up with an innovation that's called InstructLab. I believe, again, in the demo area, if you have not seen, there is an experience out there called InstructLab. This is an open source project. Again, I encourage you to check it out. The goal of InstructLab is to say, can I make model development a collaborative activity? And the answer is yes. You can make model development and evolution a collaborative activity. And in fact, the way that works is you think of the way we all learn as human beings. We have some base capabilities, and then whether you go to college or school or take an online course, you are either consuming more knowledge or learning new skills. So that's how you grow. And the same analogy is we have a technique in InstructLab where you can start with a base model from anybody, and you can incrementally improve the model by teaching the model new skills and new knowledge. It's a very interesting approach to model development that we were very excited to release in the open. And as I said, if you go look at the demonstration, you will start to see how InstructLab tries to, it's early stages yet, tries to see whether the act of developing an AI model can be made to look like the act of developing any other piece of software. Can we all incrementally improve a model and make it better and better over time? And we are very excited and hope that we start to create a global community of people who will help us improve models using InstructLab. So earlier this year, around April, May timeframe, we actually released InstructLab as a project on GitHub. So if you go to that GitHub URL, you can check out InstructLab and start to play with it. We're going to continue to make improvements to InstructLab, but really welcome participation from students and faculty and experts from all over the globe. The way InstructLab works is the following. As a developer, you use a tool to go test a model. You have something you want the model to do, you go test a model just using the command line. You figure out that that particular model doesn't do what you want it to do. Either it doesn't know about your domain, or it doesn't have a particular skill you want the model to have. You have an opportunity now to submit a change. Just like you would submit a change or a bug fix to software, you can submit something that teaches the model how to do that task. And then in the back end, your submission will get integrated. A new version of the model will be produced. That's now available to you. Somebody else can pick that up, make their next improvement, and you can start to see this loop go round and round. We started using this technique within IBM ourselves, and we saw a lot of benefit. But we concluded that actually this loop is very powerful if it could be executed in the open in an open community innovation process. So that's why we released this out there as an open source project. And we're really excited, because if this is possible, then I think we unlock one more ability for open innovation in AI beyond just releasing models in the open. And here is an example of the way we use it inside IBM. Inside IBM, we have products in manufacturing, IT asset management, etc. And what we use InstructLab is to go down a taxonomy like this and say, does the model know how to summarize an IT incident? Does the model know how to understand machine failure codes? If a model doesn't know how to do that, I'm going to teach the model how to do that. So we're able to incrementally improve the model, and this sort of gives you a picture of the way we think about it. There's a taxonomy of things we want to teach a model. We look at what the model knows, what it doesn't know, and then we say, we pick pieces of this taxonomy, incrementally improve a model. We have found this very, very interesting and appealing, and we look forward to seeing what happens in the open community as developers from across the world start to improve models. Today, InstructLab is out there with basic models from IBM called Granite models. We also support other models, and then you will be able to exercise this loop and improve models. Now, I talked a lot about open innovation, but what does it mean for IBM from a commercial perspective? This is important because you might all be thinking, okay, that's great, I can contribute to the open, but if I want to start a company or start to make a new product, what does it mean for you? So here is an example of the way IBM is taking open technologies, bringing it to market. What we have is a layer of 3 products. The first product is RHEL AI that's going to come to market later this year. RHEL AI essentially embeds AI capabilities into the Red Hat operating system. Basically, the Linux operating system, Red Hat Enterprise Linux. It bundles together a model, InstructLab, as literally a bootable image that, depending on your use case, can be installed by a developer or can run on a single server with a few GPUs. So that gives you a starting point, the cheapest way, if you will, to start to experiment with Gen AI. As you start to scale up, you want to now run multiple models, run over many, many servers. We give you support for something called OpenShift AI. Again, all based on open source technologies. OpenShift AI will bundle every one of the open source technologies that I talked about in the last 23 minutes. But now as a supported product offering that you can use to build a business. And then when you go beyond just experimentation to really wanting to support enterprise-grade applications, then IBM's watsonx platform, again, is based on the same open source technology, but then comes with enterprise-grade security, governance, developer experience, everything you need to really build enterprise-grade application software. So hopefully you get the picture of how open innovation can rapidly allow you, whether you are a startup or an ISV or a company, to tap into innovation not just from yourself, but from everybody out there, but still find your way to monetize and capitalize by bringing that innovation to market. Again, we are very excited about this new suite of products. We believe that contributing to open innovation and being able to commercialize is sort of the best of both worlds, and this is a strategy that we are going forward with at IBM. But the last piece of our open strategy that I want to talk about goes beyond technology. So you heard this morning that AI is not just about IT anymore. It really is about a game-changing technology that's going to affect many, many aspects of our life. So governance, policy, ethical uses of AI are important considerations. And we believe that we needed a forum that would advocate for the importance of an open approach, not just on the technology front, but more even on the policy and governance front. So late last year, IBM, with a series of global partners, kicked off something called the AI Alliance. The AI Alliance is the largest body of multidisciplinary, diverse institutions. It includes academia, it includes industrial research lab, it includes government, it includes national labs, it includes startups, it includes foundations like the Linux Foundation, the richest ecosystem of members who are all committed to an open approach to AI, but looking beyond just the technology into also policy, ethics, regulations, etc. We are very pleased with the interest that we have seen. We now have several projects affiliated to the Alliance that are kicked off by all the people you see on the screen. And I don't know if you see it well, but this is the global map. Literally every region in the world has members in the AI Alliance right now. And we're also starting to see new projects come out of the Alliance that hopefully will become new open source projects that all of you can contribute to. What are we focused on in the Alliance? Really 6 major areas. One, of course, advocacy. Advocate for governments across the world why it is important to invest and support open innovation in AI. We're focused on trust. We're focused on developer tools. And then, of course, we are focused on core technology, models and hardware, and then on skilling and education. So pretty much looking at all aspects of AI and what it means to take an open approach to AI. And we have a set of institutions with a lot of power, both influence, commercial power, and investment power. And we are very excited that this community is coming together to support an open approach to AI. So to net it out, as far as IBM is concerned, we are very clear that we want to embrace, support, an open approach to AI. Our open innovation approach has really 4 pillars: contributing models in the open, which is our Granite models; enabling model development in the open through Instruct Lab; contributing to key technologies that are going to be foundational to the emerging AI stack. Those are some of the projects I talked about. And finally, looking beyond technology, really participate and contribute to an AI alliance that looks at not just technology, but advocacy and policy. So thank you for your time and attention. Hopefully this gave you a sense of what we are doing in open innovation. Thank you for your attention.
Thank you so much, and we request Mr. Sriram Raghavan to stay back as we have a small token of appreciation, a plaque to be presented for all the insights shared.
Thank you.
And we can honor him for his time with a huge round of applause, everybody.